Hello, you are welcome to my class today. How are you doing today? I hope you are doing good. Now, in this class today, I want to be taking us on heat change at constant pressure. My name is Dr. Kingsley once again. Heat change at constant pressure. Now, that is thermodynamics. Now, according to the first law of thermodynamics, change in internal energy, okay, is equals to heat absorbed minus work done by the system. Now this is heat. If we make heat the subject, it becomes change in internal energy plus work done. Now if you look at this, if the heat is done under constant pressure, what will the value of this heat be? That is what we want to factor out this morning. Now we know that this work done is pressure multiplied by change in volume. That is to say that heat will become change in internal energy, okay, plus pressure, change in volume is V2 minus V1. But remember, this is change in internal energy. So change in internal energy will be final internal energy minus initial internal energy. Then plus, if we open the brackets, it will be P times P2. That will give, P times V2 will give us PV2. Then P times minus V1 will give us minus PV1. Now, let us collect the second initials, that is E2 PV2. If we collect these like terms, we'll be having E2 plus PV2, okay, will give us minus E1 minus PV1, 2 then 1. Now if you look at this, you find out that that our Q will become E2 plus PV2, okay, then minus you have E1 plus PV1. Remember, when you use your negative to open the bracket, you go back to this. Now, but we know that that enthalpy change is equals to internal energy plus PV. That is enthalpy change for a system. Enthalpy change. Enthalpy is the heat content, okay, is equals to internal energy plus pressure multiplied by volume. Now if you look at this now, compare it to this, you see E plus PV, okay, here, but this is 2, so that means that our Q will become E2 plus PV2 will give us will give us a H2. So we have minus, okay, E1 plus PV1 should give us H1. Okay, look at it very well. We say that enthalpy is E plus PV. And here we're having E plus PV. So this is enthalpy 2. Why this one is enthalpy 1. But we know that enthalpy final minus enthalpy initial will give us change in change in enthalpy. So what does it mean? It simply means that that heat change under constant pressure is actually equals to enthalpy. So note it as a summary. Remember the former class I gave you, or I told you that heat under constant volume is equals to change in internal energy. Okay, if you like, you can use this kind of change, no problem. That means also today I told you that from what we have gotten already, we can now see that heat under constant pressure is equals to change in enthalpy. So always remember that heat under constant volume is a change in internal energy, while heat under constant pressure is change in enthalpy. I'll be bringing you more of this teaching with their examples. Subscribe to my channel, share and like my videos. Thank you very much.